So if I go live, it's already saved on YouTube directly, right? I don't need to do anything later. All right, cool. So that's much more convenient. Awesome, guys. Let's go. So yeah, so talking about the rough roadmap we have come up with from last East Prague workshop we had internally, and today releasing the 1.3. It's not many main features, mostly maintenance related things, bug fixes, code coverage, and we do have a now unified app registration. So that's one topic actually I want to just mention to Sam, that we do like the example start migrate to the new API. I created a API to track it. So use a register app with key instead of register app. The register app is being deprecated. The register app with key is one that we should start to use. On testnet, the key should be left empty. And also this API will have a expiration built in, so that when we give out key, it's going to be valid for a period of time, so that they don't need to come to us for a while, right? So that's also save a bit of time for us. So the old API would still work, but only for testnet, anyways, and we're deprecating it. So if we change our examples to new API, it'll be better for the app development.
Cool.
Other things like Solidity docs we also shipped. We also migrate to using ABI.encode core. Yeah, as I said, coverage also up, and we have a wiki area slightly more organized, so there are a bit more documentation now, and with the structure here, so technical level information will continue to improve here. So if you have like more deeper technical question, we can start to give out some of the links here. Still in construction, of course. Right. Okay, so let's come to the protocol roadmap. So there are a couple of new things, new concepts coming up, so it might be interesting for you to tune in a bit in detail if you haven't, it wasn't a part of the conversation last week. So one of there are several focuses in terms of from EVM v1 to EVM v2. It's not going to be a rewrite per se. It's more of just a yeah, think how you want about v2, but it's not a rewrite. So it's still incremental change, but there are a lot of new things thought out, and it could be well, definitely exciting from a composability perspective. We're also going to push a little bit more production apps to use this composability a bit more in production, and to focus on the decentralization and network values improvements in terms of off-chain and stuff, and something related to security also, right? So these are the EVM related. I think we'll today only go through the EVM stuff. So the top level thing is the more composability. Let's go through some of the concepts. So in the Q3, we intend to ship 2 major features. I think agreement forwarder probably even be earlier. So that's kind of stepstone for the token-centric kind of functional refactoring, which is a bigger step. In between, we can use our currently trusted forwarder feature in the host contract. Trusted forwarder is a feature was mainly developed for meta transactions. So it's a forwarder contract that has limited forwarding functionality, so limited smart contract risk, but focused on meta transactions. But we could use also for other use cases. In this case, we'll use a trusted forwarder feature. So let's just go there to show what it is. Forward batch call, right? So it's EIP 2771. So the same interface as a batch call, but it is a forward batch call. So it's not called by the intended message sender, but by a trusted forwarder defined by the EIP 2771. As you can see, it was mainly developed for native meta transactions, but the concept stays. So there's a message sender encoded in the core data, which is hidden from Solidity ABI interface, ABI convention, but it's accessible through the assembly code. So through this, we could have a agreement forwarder so that I think the one of the tagline account, I think to summarize is that it's more discoverable for the block scanner. So currently you cannot see create flow from block scanner easily because it's all core agreement. That's an entry point. So it kind of confused the heck out of most people, right? So token centric could solve that, but that would require a slightly deeper. Doesn't intend to be a hack, so it should be a slightly deeper refactoring. But this one is Joshua suggested to have a intermediate stepstone. I think it's a good idea, so why not? Of course, trying to avoid being kind of blocker in the future, of course, for the token centric release. But with this, we could have a discoverability, so you can actually see the create flow, create index through the forwarder contract directly. So that would be the new entry point. Burn a little bit more gas, I guess, but yeah. So that's the agreement forwarder. If anyone wants clarification, let's do that. I think, personally, I think it's more of a UX kind of changes. Maybe debugability, but if you use Tenderly to debug, probably doesn't make a difference. But there might be a discoverability improvement. Okay, no comments. And the next thing is a Delegation Super App. So it's a composability for existing accounts and multi-sig, especially multi-sig, right? So if you have what is it called? Gnosis Safe smart contract, multi-sig, and if you want handle callbacks when someone sends you a stream, or yeah, and you can register a super app, a different type of super app, which looks like a regular super app that we're familiar with, but can handle delegations, right? So you delegate as a Gnosis Safe, right? So someone sends a Gnosis Safe stream, and the Delegation Super App is called, and then you do some extra actions, or maybe even on behalf of the Gnosis Safe to do some string operations, right? So it's kind of an implicit ACL even, right? So the super app kind of delegated to do something on behalf of the Gnosis Safe multi-sig. So that's the Delegation Super App. I wonder if it's understandable, this feature.
Does anyone have any questions about this one? Because I think it could be pretty big. I mean,
I do, actually, yeah. Yeah, I'm sorry, I'm not sure if I understand. So Super App is delegation to Super App from multi-sig. What is the relationship between the multi-sig again and the Super App? So this solves.
So currently you can't handle any actions for the multi-sig, right? Because multi-sig cannot be registered as a super app. You can't even add logic to that, right? So there's no way you can compose anything. So that's why it's called composability for existing accounts on multi-sig. Existing accounts can even include your EOA. Imagine that you delegate your EOA callbacks to a super app, right? So if someone sends you a stream, yeah, it's delegated.
Oh, Okay. An EOA could delegate callbacks to a specific super app.
Yeah, I think only one would make sense.
Yeah, so then when you open a stream to the EOA, the host will check, has this EOA registered any callbacks? If they have, it will execute the callbacks as if the EOA was the super app.
Wow. Okay. Now that is interesting. I'll give you that. Okay. I'll have to think about that. Thank you.
It's similar to the mechanism in ERC 777 with operators.
Yeah. It's kind of Are we stealing idea from 777 again without calling it this time?
I actually saw it there. Like I had this idea when I was looking at the API because I realized that they have two parameters, right? When you're registering an ERC 777 callback, you actually repeat your address twice. And I'm like, why are you repeating it twice? And Nuno explained to me that it's because one is the target. It's not necessarily yourself.
Yeah. Operator, right? Yes, delegation, operator. Operator, we don't already use it for ACL, so we kind of need a different term again.
From a super app level, if anyone can delegate now to your super app, correct? Like, does a super app have any? How can I stop anyone from delegating to my super app?
Question. You probably want to white listing, right? But it's not a regular super app. It's not any super app. Ricochet cannot be claimed to be a delegation without the code changes, right? So it has to be one that registers delegatable kind of service.
Okay.
But we have app manifest, right? We finally have a new flag for it, I guess.
Because if you have a super app, this with solvency, this becomes a little bit. If you have kind of potential many people just coming in, because we still have the many to one stream pattern, like there's still the duplex issue.
So the super app itself doesn't need to have liquidity. Liquidity is only provided by the delegating accounts, right? So super app is just logic. So you have the smart contract logic is outside of your accounts or multi-sig smart contracts. So those are the ones that actually matters for the liquidity. The delegation super app is for the composable code logics, if that makes sense. It's like it runs certain operations for you, but it uses your liquidity.
Yeah. Oh, okay. Even borrows liquidity. So even I see. Yeah, very nice. Okay.
It's as if your contract, your address has code, I guess. But then, Meow, what happens if there's state?
If there's state, so you can store state for the so you have to manage the states for each account. Yes. So the smart contract does remember states for the accounts. Yeah, there's still accounts with state you can store in the smart contract. So you can't change storage for the EOA or for the multi-sig. There's no permission for that, right? There's permission given by the Supra token and Superfluid framework. Those are the one permission we give, but the delegation super app cannot change data for the EOA and the multi-sig smart contracts. So if the delegation super app wants to, let's say, maybe we can think of a use case, right? So if someone comes up with use case, you have a multi-sig Gnosis wallet. Sorry, Gnosis safe. Gnosis safe. Someone sends you a stream and you want to do something about it. What do you want to do? Maybe send to what could be?
Could even just be emitting an event.
It's a trivial case, yes. meeting
or
events to
minting an
trigger,
NFT.
yeah, trigger EPNS automation, right? Event is important.
All right, EPNS.
Cheap way of triggering events.
Mint the soulbound token to the sender.
Sender, thank you very much, token. Thank you, token. Thank you, NFT. Well, I don't know, I forget what tax, but
Yeah, for example, when the stream closes, could be receipt NFT.
Yeah, we'll also redirect, let's say, 20% of the stream to something else, right? Well, the complication here is is it a two-level app anymore, right? If you want to redirect 20% to Ricochet automatically, is it two-level app? That's a tricky question. But if it's not to an app, just redirect 20% of the input to another EOA as your piggy bank automatically, right? So that doesn't have a multi-level app complications, but simply as a redirected savings. That's already a use case. I could think that's a use case, right? So the treasurer, let's say, receive a subscription service fee, and 20% go to my savings code wallet. And if the stream stops, it deletes the code wallet stream. So kind of automated cash flow for the MDC. That's another use case I can think of.
We still have the multi-app issue, multi-level super app issue, like you said. So if I delegate my rights to this super app, won't be able to stream to another super app.
That's slightly different, but yeah, I mean, definitely listen carefully. I mean, we never wanted to enable the super app, super app, right? But in this case, it's a delegate super app to another, like Ricochet. It's tricky.
Yes.
I don't know if you want to go deep into that, but as you can see, there's a lot of design surface already, even just without the super app to super app. It's already use case, just as like a piggy bank case or issue an event for the EPNS automation. All this, I think it's a valuable feature to strive for in the Q3. That's why I selected it.
Yeah, no, certainly. I mean, yeah, it makes sense. It's just thinking about from other super app developers. Essentially, if you're a super app developer and you get your users or accounts to delegate to your super app, and if you can't do super app to super app, then essentially you have completely owned that relationship. Anything they can really do. Okay.
Maybe at some point we should think about a pattern, how to compose multi-hop with multiple transactions.
Yes. So that's definitely tricky. Could be app specific mutex, so that make sure that the app itself doesn't have a reentrance, right? So adding a new field to the Superfluid host transient. That doesn't need to go to context probably. Context is already big, but just go using storage and clean it up in the end. So as a kind of mutex app level mutex, if you know what I mean. So to make sure that the app itself doesn't get re-entrance. That's one way to implement. But it's definitely needs a bit more thinking carefully here. I wouldn't do too much experiment without go through the design carefully. So currently we have a global mutex, right? So it's kind of app level thing. Once you are in the app callback, you can't call another app. That's kind of global level mutex. So simply we don't allow multi-level. When you have second level, more granular mutex would be the one already got a callback, should not get another callback within the same callback chain of callbacks. That type of mutex, that's easy protection. one of the easy protections could do.
As a Super App developer, could we simplify the process where essentially if we also started introducing our own reentrancy guards? So I know from a protocol level perspective, you can't really make assumptions about how people write super apps. I mean, maybe you can, but suppose you could, Meow. Suppose we had reentrancy guards on all of our callbacks.
Mm-hmm.
It would simplify the way you reason about it. No?
So let the super app does a reentrance protection.
Yes, essentially. So you can't re-enter. But is the question about multi-level super apps? Is it about re-entrancy to within the Superfluid host framework, or perhaps I mean, there's multiple types of re-entrancy into the same super app, re-entrancy into the host framework again, etc.
Mainly about the super app level, so that your callback doesn't get re-entered within the same chain of callback twice.
Okay.
I think in general that should be always there. Not sure if I would. Not sure if it's a good idea to give app any opportunity to shoot themselves in the foot. Another way to think about is maybe we could allow, but if it poses a systemic problem to the framework itself, then we definitely shouldn't allow. But it seems mostly an app issue, right? That's one issue which is re-entrant. The other issue is the amount of buffer and the amount of gas cost for the termination callback. We need to say currently we have 3 million gas cost protection for the termination callback. So your app cannot block the termination by using up all the gas, right? So that's one of the protection already built in. But when you have a second level, then each level uses a bit more gas, right? So there's additional thinking needed. So that's basically one of the design challenge that the point level that we never wanted to actually properly address until proven necessary to address it.
Yes, makes sense.
Right, let's move on. I think when we start to do it very soon, which we can brainstorm a little bit more, and as you can see, there is already a second level app issue, but maybe we could, if it gets too out of hands, at least we'll release one that without multi-level issue. And I think the GDA and flow distribution will definitely push for it. I think we went through the design of the current IDA contract data and account data. It should be doable. So smart contract level should be doable. The difficult part is the off-chain part. So we need to also upgrade the Sentinel infrastructure to understand the GDA in terms of its solvency implications, for sure. Yeah, and then move on. This one we talked about 9 times already. Finally, let's just do it. If the other thing that is the state-of-the-art batch operations to keep up with some of the new advancement in the batch operations. I think it's still a dynamic topic. I don't know if there's any winning solution yet. But as far as I know, there are some new idea came and it's promising, right? So Didi, if you want to comment more, please about that to everyone.
Yeah, there is a delegatable if. I don't know if others have seen it. So that's by Dan Finlay from MetaMask. who seems to have been thinking about this for a long time, and is trying to have a framework which includes, which allows for different things like batch transactions, meta transactions, delegations, etc. And he also provides prototype implementation here. So I've recently checked if there's attempts to, I don't know, have an EIP or Ethereum magicians. I didn't see anything so far, but I have some hope that, yeah, that's being picked up, because I think it would be good to have such a generic solution as a standard, not every contract somehow come up with their own patterns of ACL, etc.
Should I be obnoxious and say that the indent size is 4 in Solidity, but actual code is not 4? Sorry.
So we can't use it.
No. Look. Sorry, it's in recording. I'm being obnoxious. Sorry, but yeah, this bothers me. But yeah, I mean, it's what I meant here. The state of the art advancement. Even the native native EVM batch core was at the time I was looking into it, but I don't know what the status. Let me search about it. Native batch core, which EIP is it? Who remember? This is pop quiz, EVM pop quiz.
Is this the same as user operations, or do you mean something else?
EIP native batch cooperation. Not this one. Transaction package. That's one envelope. Right, that's where. Is it this one? Maybe I'm mistaken. Oh, found it. Oh no, no. There you go. Typed transaction envelope. No, it's final. What is it called? Batch. But it definitely can batch, as far as I remember this one.
Maybe that you mean 4337. That's about account abstraction, and I think would imply the possibility of batching.
Yeah, there's a collection of stuff that relate, right? So this one reference to this one reference to this one, and what's the other one? 47, what for account abstraction, right?
Yeah, 4337.
Yeah, I'm gonna list all the links.
I mean, account abstraction goes back to, I think the first one was 86 or so.
Yeah, on this list there. I think it's definitely worth to look into the state of the other one and upgrade our ad hoc bespoke batch core solution to something that's promising to become a standard, but also at the same time avoid the EIP 777 case that we choose a wrong standard and is stuck with something that is not gonna come out anywhere. So that's a harder call to make. Okay. Any comments? Extracting from the step. So what's next is the existential agreement contracts. This means that for agreement contracts, meaning a flow definition, a flow contract between sender and receiver, that's one, right? And a subscription contract between the publisher and the subscribers, that's another contract. We call it agreement contract. So that's a piece of data like describing relations between accounts. Making it existential, meaning that make it something that exists in the blockchain as the kind of first class data structure, which is basically contract, right? So that means ERC 721 flows. Did I correct this one? Yes, 721, the NFT flows and the distribution as transferable, potentially transferable ERC20 tokens. So natively, so each time, so all the agreement contracts would have some sort of token representations, and they will have a standard token interface, be it NFT or be it ERC20. As a side effect, as Didi also mentioned, that this could be also a chance to us to retrofit. I don't know if it's directly related, but it could be a chance for us adding that multiplexing. So currently, sender and the receiver is only have one flow between them, and one of the easy multiplexing fix would be adding an integral number, and it's backward compatible. So 0 number is the one that backward compatible and it will support, and then we can add sequential numbers on top of it so that it doesn't conflict with other hashes when storing the agreement ID in general, so that we could have multiple stream IDs between sender and receiver, especially when you tokenize them. That would be sufficient, would be convenient. Let's say in diagonal case, for example, if you receive a flow from multiple subscribers to the same account, current that's not a good example. What would be a good example? So multiplexing. Sender and receiver having multiple streams, logic stream represented in different NFTs, but with the current CFA construction, they would look like just one flow, right? Everything merged together. But make it existential. Probably that's opportunity for us to actually break it down in a higher level, so that we can have multiple streams between the same sender, between the sender and receiver with a stream ID. There are technical details regarding how to recycle the IDs so that they don't keep incrementing. Maybe that's not a problem, I don't know, but let's not go to that detail. But the idea is to have multiplexing using this opportunity, perhaps.
Yeah, I see another question here, and that is about the stream identity itself. Because if we talk about stream as something which can be forwarded to another receiver, then the way the identity is defined now doesn't work, because currently it's just the agreement identity, and agreement identity is sender receiver agreement type. So what we could also do is to say stream identity is a different thing, and we construct it such that it can be forwarded.
Yeah, I think the existential layer could be the one that create new semantic on top of the underlying. So we could start to treat the underlying a bit more lower level, kind of link using network analogy, right? Like a link level thing. You don't necessarily need to care that it's between these two lower level entities, but the higher level, you abstract the meaning away. It's like you have the actual NFT represented a transferable flow
Yeah, because you could, for example, construct the NFT such that you can transfer it, and if the receiver already has a stream, then it merges. That would all be possible. Where it gets, for example, tricky is then if the new receiver uses the low level functionality to update the flow rate, then it's actually not clear which of the both layered streams is actually changed. So questions like that arise.
Guys, may I ask, when you say ERC721 flows, what do you exactly mean by that? Yeah.
It's about having a 721 representation of the stream.
Of a stream, okay. Yeah. And when we say ERC20 distributions, is this the agreement type where a constant balance agreement we've mentioned before, constant transfer agreement, kind of this idea of you can have a step function like boom, and then
No.
next period you go boom. That's not that.
No,
No,
it's for
that's-
the IDEA units, simply. Yeah, representing IDEA units directly in the ERC20.
As ERC20, okay, representing IDEA units, okay.
So that's about generalizing the index concept.
Yeah.
And then so that it becomes composable with any agreement.
And then you can have streamable IDEA indexes.
Yeah, then the idea is if you stream to an index, so the index would then be represented as a contract. And if you stream to such a contract, then the flow is distributed according to the distribution of the units, aka tokens, if in ERC20 lingo, as defined by this contract. Because the units, it's the same principle as a mapping in ERC20. It's a list of address balance tuples, and units is the same. It's just address, number of units. So you could map it to the ERC20 interface. And by making it, so right now the index is embedded in a specific agreement. And if you make it standalone, then not only is it bound to a specific agreement, but you can actually have a semantic where you say if you send or if you create an agreement to the index, then that's basically what the GDA would have, what the GDA is intended to be.
Yeah,
So we don't need to have explicit variations of every point-to-point agreement for the one-to-n.
Yep.
So the kind of separation of the representation of units with separate from the representation of the way it's distributed, right? The way distributed could be instant streaming or other type of streaming, but the representation of units become a separated concepts. So decoupling them and make it more, so AKA general. All right. I think we'll just use 10 minutes to go over the composability more, and we'll not go through other levels, otherwise we'll never finish to the next topic. But I just want to show that the beyond decaying flow, not going to mention it again, it's still yet to find the actual good use case for it. But token-centric is something that I want to make a comment about, including the functional UI. So I have this control flow, the potential control flow if with a proper refactored different flows, so that Alice would create flow through the token directly, and the token would interact with the host through a different implementation of call agreement, which will not be exposed to the user anymore after this migration. And then we'll actually go through the functional CFA refactored implementation that the instructions are queued up and committed to the token at the last stage. So that's one of the idea. This optional part are the one that handles the lifecycle callbacks, right? The green part are the Super App callbacks lifecycle. The Super App may also do nested call agreements, right? Like the Ricochet case, for example. That's a Ricochet in this. Yeah, it is call agreement, including the IDA distribution. So these are optional part, and then in the end commit to the changes. So it's kind of defer the side effects to the very last stage. If we can pull off this kind of structure, would make it even easier for the functional for the verifying the specification and behavior. Yeah. So yeah, that's the idea beyond.
May I?
Yeah.
There's something which I know, just perhaps speaking a little selfishly, but there's something we would like to see very much on the roadmap, if possible, perhaps at some point, which is this agreement that I have brought up a few different times, but it's this constant balance or this constant transfer agreement. Essentially, this step function in just a regular ERC20 transfer. And this is largely coming from kind of essentially speaking to the businesses we're speaking to and speaking to our customers, where for some, having a pay by second value transfer model makes sense. And it's really interesting. For other businesses where there are, for example, larger switching costs or upfront capital expenditure, they would prefer payments to move in a step function, in a kind of dun interval. Now, doing that with bots off chain, you start running into, first of all, you start having to make trust assumptions on the bots, and you have to essentially doing this with creating a bot network to just do pool transactions reduces to building a decentralized bot network. Now, we have a nice decentralized bot network within the Superfluid Sentinel system, and we have sort of a token-centric model to view these value transfer. So, and also we have all the benefits of the Superfluid framework in terms of things like Super Apps and composability and security like cash flows. So essentially, look, speaking to our customers, it's one of the most requested things they ask for is essentially regular subscription value transfer models. And look, I just felt like I should raise it at least. I mean, this is something we think about. And yeah, I mean, being able to do this within Superfluid is still 10 times better than having a pool-based, trust assumption-based bot network, where essentially you're trusting a provider, whether it's Diagonal, whether it's Gelato, whether it's Chainlink, to run these systems, and you have to make these trust assumptions. But with Superfluid, you have the Sentinel network, and perhaps more importantly, is you have state which is tokenized in super tokens. So you are not infinitely proving someone, but you're rather wrapping into composable tokens. This is why I think it could be a really that's a massive use case which we would immediately jump upon. And yeah, I just want to bring it.
Yeah. Sorry that didn't. I think we've got even talk about it last week, but it's
Do you have a specification for it? Because I wonder, for example, how does it deal with details like months having varying number
Yeah.
of time spans, etc.
Yeah, exactly. So this, remember when we were talking about quadratic decay, so a few months back now, I spent some time thinking about this. And okay, so look, it's just like we have with the quadratic decay, we have to make certain assumptions. Quadratic decay, we specified half-lives or certain intervals. So you would want to do something similar, roughly, where you would specify, all right, you're only allowed to make these transfers on a 24-hour basis, on a week-long basis, on a 28-day basis. Maybe it doesn't have to be 30 days. It could just be the worst case scenario. Or even it could be 30 days, but essentially you specify intervals that work, because you can't just allow anyone to create these agreements, because the question always boils down to solvency, like Fran likes to tell me. So once you have the types, the real question becomes, how do you define the real-time balance of function and the flow rate function? So the real-time balance of function, I think I've sent you this before, DD, is essentially you could do floor division, where essentially you do, I don't have it in front of me now, but essentially you would do the period in some, you need to figure out the amount which you want to send, floor division by the number of periods passed to figure, I've written it down before, but I think I've shared with you before, but the calculating the real-time balance off can be done with sort of, you do time passed now versus the time passed, and you figure out how many periods have just passed.
Yeah.
And then you divide and you multiply that by how much should be moving every period. That's how you do it.
So, so it would basically be like CFA, except of you always let the withhold
Yes.
delta balance for a while until some threshold is reached, and then make it available as available balance of only such stuff.
Exactly, DD. So it's withholded, and then essentially there's a step function, like it's a clean break, where after a certain given point, your balance goes down by a large amount, the other balance goes up by a large amount. Yeah. Now the thing which I haven't really go on. Oh no. The last thing, I guess the big question is regarding solvency. What happens with the Sentinel network? How does this potentially work with that?
I wonder if we could even build it as a super app on top of CFA, because it's actually very similar to the CFA if it's defined like this.
So maybe describe a little bit from whose perspective it's more important per step. Is it for the tender perspective, or is it for the merchant or receiver perspective?
All right, I was assuming that for the sender it's okay to just have a constant flow. Is that assumption correct, Tony?
No, so this is where kind of it breaks down a little bit, because essentially what some of these businesses argue is that so the great thing about streaming is that users can close the stream whenever they want, which is great, frankly, because this means you can come and go and try different things. But for certain products, let's say we take a very expensive product, which is like analytics product, which is like $8,000 a month or $7,000 a month. Their whole pricing philosophy is based around the idea that you commit some capital, and now you've committed the capital to use the product, and now you kind of feel like you're going to use it. So just from a purely business point of view, so the thing about it is going to these businesses and so thinking purely in terms of constant flow and purely in terms of kind of flow rates, which is really what streaming CFA boils down to, is flow rates, is asking them to rethink their entire product strategy and how they think about their products. For example, their current SaaS pricing models, like doing things like yearly discounts. So, you have certain packages. If you may go to a business and they may give you $100 off if you subscribe for the year instead of if you subscribe on a monthly basis. Like all these sort of tricks, they're very ingrained in how people think, actually, more ingrained than I guess I initially assumed. So the kind of the rough idea is that you want the user as well to not be CFAing in. You want them to be also bulk paying, because that opens up the scenario for these large upfront commitments.
Well, but if but where is the liquidity in the meantime? Because if the sender has to pay it all immediately and the receiver receives it in steps,
it receives it in terms, it receives in terms of like the real-time balance of increases. So it's, if you think of it, it's sort of like they're vesting it, but the vesting doesn't happen on a per second basis, but it's just on a certain per period basis.
Because something like the discount, which works only if you keep it open for a year, that could easily be modeled by the sender having to use the whole non-discounted flow rate and the differential stream for the discount going to a contract where it's locked until the end of the year. Because if you require the sender to pay the full amount upfront, it kind of, I don't know, that's we're back to square zero somehow.
That's
I mean,
Tony,
yeah.
if I can jump in here, Tony, I mean, it actually sounds like this is pretty simple. Maybe not from like the technical implementation side, but like what the customer wants in this case is fairly simple, right? They're used to on the 15th of every month, they're on the 21st of every month, having a certain amount leave one account and go into another account. And ideally, you'd be able to, for this individual customer, say, oh yeah, we can just use Superfluid to do this exact thing that you're used to, because you're not ready to make this leap into sending and receiving the subscription payment with a stream on a per second basis, right?
Yeah,
so you're effectively just trying to map what people are used to onto an additional adjacent offering, right?
Exactly. And then you still have all the benefits of Super Framework. You still have things like securitized cash flows, which is a huge, interesting vertical. You still also have things like all the gas efficiency, which comes with that. And you also have things like you trust the payments actually be delivered. So like, this is the beach problem. Like, what happens if you wanted to do this in the bot world, you have to trust the bot to enforce that transaction every month. But if the bot stops operating, you don't get paid. But here you have a trustless network where payments are sort of optimistically happening. And it's only when you run out of balance where like people are like closing your agreements, essentially enforcing you.
Yeah. I think if we don't add a new type of exotic agreement, right? What I'm afraid adding that is the requirement may not capture everything we wanted, and we keep changing it. It's pretty hefty just to do that. But another model I think quite a general is to combine the CFA and IDA. So there's automatic part of the system, then there is an off-chain part of the system, and there's a smart contract in between to kind of guarantee that the capital is always transferred, be it automatically distributed or manually claimable, right? So that's a pattern that we can actually apply that to quite many designs, including this case and including some of the automated investment strategy or stuff like that, right? So the idea is your customer send a stream to this smart contract. It's like most likely a super app, and the super app will start to do the accounting. So there's an accounting aspect, right? And it just accumulate the flow and split the capital correctly to the one that can claim money from it. And you can add the off-chain, probably the agent, to distribute it whenever needed. So in any case, the smart contract guarantee that you will receive the correct amount of capital. Then you have also a automation possibility from the agent, from your off-chain system perspective. So there's automation offered, but there's also guarantee. So it's kind of getting best from both the world. And in terms of the case you're mentioning here, so maybe the sender would be still okay to send a stream of money, so we don't need to change anything, but use the super app as a way that handle the accounting. So purely use the super app for accounting and off-chain integration, and the guarantee that the recipient can claim correct amount of balance. This general pattern could be even applied to invest into a pool such as Aave or Compound or things like that, if that makes sense.
Meow, do you just mind repeating how the IDA plays a part in this? So you CFA into a smart contract, smart
Yeah.
contract does the internal accounting, and then you IDA out.
If there's proportionality between if there's multiple participants and the distribution always proportional, then you can use IDA. But if it is not, then the agent has to do something else, how to distribute the amount. Yeah, so that part depends really. So yeah, I guess I should have said that the IDA could be used for distribution proportional to the recipients. But in your case, this side is actually merchants, right? So there's only one. The difference is that you have multiple senders and one merchant, and one merchant just be guaranteed that there is off-chain distribution mechanism that keep the automation on, and while the smart contract guarantees are guaranteed for both sender and receiver perspective, the accounting is done correctly, even with a step kind of logic, if you will. Probably I'm speaking very abstract level. I don't know if it helps, but yeah.
Tony, I have a question regarding the discount commitment thing you mentioned. Something I often observed is that when you are offered a discount for longer commitment, what as a customer often wish for is that I can just start and can also be with the non-discounted version, but if I stick to it, I would like to automatically have the discount applied. Is that something businesses don't want, or is it just that it's not easy enough to implement?
So essentially they start at the regular version and then they want kind of the discounts applied dynamically, I guess, or after a certain threshold is reached.
Yeah, but automatically without me thinking about it. Because as a customer, I often feel kind of tricked when before really knowing the service, I'm forced to make that decision. And then if I don't already commit and keep using it anyway, then you know.
So where you see a lot of discounts is usually at the trying to get customers into the door. So like you give them discounts to get them through the door. And then those are usually temporary discounts, but they're usually agreed upon before you enter into the financial relationship with the counterparty. However, applying a dynamic discount or like just let's say a discount after a certain threshold, I can certainly imagine use cases for things like that. You can imagine rewarding someone or giving like a special month off. Yeah. I mean, there are, of course, there are use cases. I mean, the thing about payments is there's a reason there are a couple hundred payments companies just all trying to help businesses figure out how to get paid. It's because payments is a really, so many businesses have different payments requirements. And they have there are many different things you can do with payments. And we have all these different businesses actually catering to small different parts of that in the existing Web 2 world, which isn't great. But yeah, I guess the only point I want to make here is that I think it's a fundamental way of value transfer. Like streaming is on a per second basis, but value transfer on a discrete interval is also something which, yeah, I think is quite fundamental. But I guess the real, like Meow said, how do you capture all use cases and what are the intervals? I guess, yeah, I can see how that could be challenging.
Well, Tony, can you expand on a little bit more on the customer that or customers that are asking for this and what their specific use cases are? You mentioned that there's this thing where pricing models are sometimes designed around getting a large upfront commitment.
Yeah. So
can you expand on that?
yeah, so this is where we all have to keep in mind this meeting's recorded and put on YouTube.
Oh, of course. That's a good point.
Yeah. Yeah. So we can talk about that afterwards, Sam. But look, I don't
Sure.
want to. That's why I don't. Yeah. But
Sure.
then I can tell you.
I
about
guess
that.
maybe can we talk about the archetype of situations that this might come up in then, right? So you mentioned that there are situations where if let's say I'm a SaaS provider and I've designed my pricing model around having some kind of large upfront commitment for whatever reason.
Yeah.
Is there any more to that story, or are there other types of situations that tend to come up where
So
streaming becomes an issue?
Yes, there are two main things. Look, so I largely think it's a misguided belief. So essentially, we're trying to convince people to move to streaming. That streaming this is a good way for your business to get paid. Now, from a business point of view, you have designed your product and your pricing models largely in other ways. So let's say you have a plan, which is $100 a month, and then you have the yearly discount, which is nets out to being like $80 a month. So you have these different pricing plans you have created, and you have your existing Web2 payment system, which you already handles this perfectly well. Now, you of course have some clients who want to get paid in crypto, and you want to cater to them. Now, how do you cater to them essentially? So first, just from a purely business point of view, you want something which kind of, and in some of these cases where they have a lower risk threshold, you want something which integrates seamlessly at first. Because they kind of trying to convince them that the whole idea that giving the user all of the power, so the user can just come and go as they wish. Like certain products are built on, let's say, exclusivity or members, or you can even take a DAO tooling product so you could go to a DAO tooling provider, which helps you with human resources or treasury management. You go there, you set up your organization, you import all of your customers, you set up your whole team, and then does streaming really make sense in that case where you can just hop in and out of this use case? Like the argument with streaming, which can be really powerful in the correct business scenario, is that you can make the case that streaming empowers your business to onboard a whole new cohort of customers. Because essentially, there's now a pricing point for every single customer along the demand curve. There's a pricing point for someone who wants to stream and pay for your service for 1 second a month, for 10 seconds a month, for 10 minutes a month, for 30 days a month. And that's a really powerful argument you can make. And that makes sense for businesses where the amount of how value is distributed is largely uniformly across the month. So like Netflix is a great example where you pay for Netflix subscription, and like the way Netflix distributes your value is essentially by watching Netflix, by time. So time is priced. However, for businesses where time is not the value metric, it can become a little more tricky. Now, yeah, the other thing, go on.
Quick question. So which comes to mind here to me is hosting providers. For example, at Hetzner, if you take a server, then based on which one you have a one-time setup fee plus the monthly bill. So I wonder if such a combination of setup fee, or however you call it,
yeah,
plus the time-based one, if that's something which would work in many cases.
Possibly. I mean, we floated. Yeah. I'm not saying it wouldn't work, did it? I'm not saying that. It's just.
Yeah. How about
Yeah.
let's have a
We can
dedicated time unrecorded so that Tony can speak anything. An unrecorded session that let's just talk about the payment in general. I mean, I understood the mismatch between the customer and the merchant, right? The customer wants to pay as late as possible. Streaming would be ideal, but if I use any service, they ask me to pay 1 year later, I'll be the best. But the business wants something different, which is they want you to pay now in advance, just falling. So there's such mismatch, and the kind of I've never get my head around how to resolve that, to be honest. So it would be good to hear what you have to say after you're talking to someone business about it. Yeah.
Yeah, thanks, guys.
Okay, let's do that. I'll organize a call and let's do that in a unrecorded session. Now we have 14 minutes to discuss the rabbit hole, which is great, so that we don't go to the rabbit hole. I'll make a rush decision and we'll go with it. Sorry for my sarcasm sometimes. Less people enjoy nowadays. So what is it? Oh, app credit. So we have this, to recap, the app credit is because of a buffer used in CFA. A Supra app would need liquidity to create streams. So we created some, in order to support large volume Supra app. And we don't want the app developer to put up initial liquidity, right? So we create this kind of zero liquidity requirement when we designed the Super app system, and now it is named app credit after a couple of renamings. So the objective end is to use one-to-one flow forwarding as a benchmark case. This, to be sure, it is working. Right, so one-to-one flow forwarding with the exact same flow rate, it would work. There's no issues. The objective, that's objective. We had actually another objective that doesn't allow the app to shoot themselves in the foot, which means if you create a flow rate is larger than the incoming flow rate, you would trigger a revert in the callback, and but now it's not 100% like that because of the clipping. So sometimes you do bypass that rule by simply creating a flow rate that is slightly larger than the input, and you have a chance at creating a super app that is draining the super app balance ever so slightly. Then the Sentinel will come in very shortly afterwards and jail your app because the app is draining your zero balance contract account, which is bad. So it will be jailed. So that was objective, and that was the one of the trade-off also after the default thing. Sorry, buffer thing. So yeah, there's, you can read about this. I'm going to send this link in the chat. Right, so we have a known problem that the one-to-n flow forwarding is always an issue, and we're finally going to fix it. There are possible two fixes. We had a discussion before, but now we're going to pick one and implement it fairly soon. From next sprint, which is next week. I personally would go for the additional minimum buffer as app credit. It's simpler, so easier to reasoning, and it gives you a larger chance to shoot yourself in the foot, but so be it perhaps. So to recap, so by default, minimum buffer is the minimum clipped buffer amount. What does that mean? Just do a raw calculation. So one, that's amount, right? So 1E18. There you go. So it's 4 to the power of 4E minus 9. So it's negligible, small amount of buffer. That's the minimum buffer by default, but we're also enabling a minimum buffer for some networks in the future, especially if we go into a Ethereum mainnet. We'll definitely enable the minimum buffer for the for some tokens. And
Could you repeat that, Miao? Ethereum mainnet?
did I see that?
Or was that a slip, or am I hearing things?
No, it's I mean that feature is definitely geared towards the Ethereum mainnet. It was also for layer 2, but so far layer 2 kind of let it be, and didn't seem to be a
Okay.
issue. Yeah, so but mainnet definitely would have a minimum buffer in the tune of perhaps $5 to $10. Yeah, I don't know, depends on the gas price.
Yeah,
Nowadays, gas price is not predictable these days, but yeah, so minimum buffer. So you would definitely just pay a floor buffer, floor price of buffer, and so the additional rule would be each time the app create a flow, additional minimum buffer added to the allowance, so that the app could create a flow, and with additional minimum buffer guaranteed to be available for the allowance, so that you would never run into an issue that you don't have enough buffer for forwarding exactly the same amount of flow rate added together by n subflows, right? So that's the kind of target case you want to try to fix. So yeah, ensure the app can always create a flow, actually create flows. I will fix that. We already abandoned the objective, and we kind of abandon further that app now have even larger chance of shoot itself in the foot. But still, it's manageable. So I don't think it's a huge problem for app to implement correctly that logic.
In what way can that be a problem?
So the one-to-n forwarding issue, right? So if you split the flow rate into n, and you add just ever so slightly little than what you were given to from the input flow, you're basically going to create a net flow of negative amount, right? So the initial objective, very early days, was that you shouldn't even be able to do that. That would work in one-to-one case without clipping perfectly. But with clipping and with the one-to-n, it's already very difficult to keep that rule. So we want to make one-to-n flow splitting works perfectly. But if you add a little bit of residuals to your subflows, you would drain your super app, and the Sentinel will come and liquidate you very quickly, and then your app is jailed. We can talk about jail rule in the future. This should be jailable event, but a separate topic. We kind of missed the chance to talk about last week regarding if all the jail rules make sense. Maybe we can have a fine instead of jail kind of intermediary stage for some cases, but that's wrong on a tangent. So yeah, is that clear, Joshua?
Yeah, it makes sense. Thank you.
Right. So that's the I'm pro for the fixed one, but BD, if you want to defend your proposition, would be change the CFA1 rule, which is using round down instead, and need a math proof that it actually works. I think the proof is trivial. I don't think need actually any proof. But the third one would be to me, it's a drawback is that there's no minimum buffer economic cost kind of case. So I consider that slightly more complicated.
Yeah, I think the last point is the main drawback here. So the idea was to ensure that as long as the app doesn't have a accumulated outflow which exceeds the incoming flow rate, that this will work, and that could be achieved by rounding up the app credits and rounding down for the other flows which are going out. However, that is the case only as long as as long as the minimum deposit is not applied, or not just that, also it can't be below 1 of the clipped deposit. But now you say it abandons the objective that the app now could shoot itself in the foot even in the one-to-one I'm not sure if I understand how could it do so in a one-to-one case. Is this related to a case where the outgoing flow rate exceeds the incoming one, or other cases too?
Yeah, I've got miswritten here is that in one-to-one case, since we round up the buffer amount, right? Oh, you could basically, right? So because you could create a flow rate because it's rounding up, right? We can create a flow rate just one way per second above the input rate. So you're already draining account, and more likelihood that the deposit is actually calculated the same because of clipping.
Okay,
Right,
so it
so-
is about a case where the outgoing flow rate is bigger.
Yeah, so that's what it's meant here.
Okay,
about
but-
shoot itself in the foot. Yeah.
Yeah, in my opinion, that's something we shouldn't really be concerned about. Is if an app is doing that, then they better know what they do.
Yeah, I think that's why we kind of okay to just abandon that objective. Initially, when it was designed, somehow it was very. I mean, you can see the traces of how the Super App framework itself. Yeah, there's a lot of protective and nannying, right, including jail for the user, for protecting the users, including this kind of apps. Yeah, so there's a lot of overprotective measures. So in this particular case, I definitely agree that there's no need to protect further there. Just let the app to jail the more. All right, that's great. Where's Vincent, the one actually doing the work? Yeah, well, sounds great. Any more questions? We have 2 minutes left. What more topic we can talk?
What is the state of the minimum buffer development?
It's live.
Yeah.
But
Oh, sorry.
we haven't enabled. Yeah, it's like we
Okay.
haven't enabled. Yeah, because of this particular app credit issue, we kind of hesitate to enable it. They might conflict with how app Super App works. So once this is done, we're gonna. I don't think we'll enable for any of the network that's relevant for now. But it's more of a preparation for the mainnet. And
I think on the L2s it could make sense to.
yeah, it could, and also that's kind of linked to the economic value of civilian services, the way I call it. So basically, the Sentinel is not paid enough, right? So they are on strike. No one works for Sentinel. I said long life. Yeah. No, we have.
Often we do.
Yeah. So yeah, provide more economic values. The protocol in the non-civilian service quote level, which is the protecting the solvency, right? The civilian service would be something in the future that some of the non-critical functionalities could be covered by Sentinel in a decentralized way, so they have more economic value can be extracted from being the Sentinel. It's like peacetime services, let's call it.
I may be pushing my luck here, but the mainnet, where do you think this lies within the roadmap?
Yeah, it's not listed here. Don't want to over-promise here.
Yeah.
In all likelihood, after app credit, I don't think it's a problem for us to go mainnet. But the way the community will run it, will probably be different because app minimum buffer, right? So maybe we'll be very careful what token actually list in the resolver. And stable coin first, and perhaps native ETH first also, like the L2s we do. That'll be very soon. That means if we get the app credit done,
Yeah.
depends how fast Vincent is with him.
Very cool.
Yeah.
Tony, is there a demand specifically for mainnet from?
Yes, there is a lot of demand, especially from DAO tooling providers, because DAOs currently have most of their treasuries on mainnet. Even the people, they have some liquidity maybe on some of the side chains, but they still prefer to do most of their economic activity on mainnet, even if the gas is a thing. Yeah.
Mhm. I mean, this is a scalability solution per se, so I guess there's case where it would actually make sense.
And it'd be a great feature though.
Yeah, right. I think we're on time. Great. Good timing always. I wonder why. Even Tony hijacked 30 minutes. We still managed. All right. All right. Thanks.